Welcome everyone in this second lesson of Womp3D. Today we will look at the first steps of building shapes and all the options of interaction between them, as well as the characteristics of the materials we can attribute within our scene. We always start by opening a new project and we will get the same initial scene that we have already analyzed but not fully understood in the last lesson. Let's start with the assumption that everything in modeling is created through primitives, which are nothing more than a collection of the program's default solids, which includes the most common shapes of three-dimensional geometry, such as cubes, spheres, and cylinders, with the addition in Womp of some special objects that we will see in the future in the next lessons. We find them all here in the first icon at the top left, as we mentioned in the last video, and these shapes can then be joined, subtracted, and merged together. We have said that on the left we will have shown the shapes that we will be creating, and we also see in this initial example scene how these three shapes fall into a union whose components can be either selected individually or simultaneously all together just by pressing on union. In fact, it will show a cage here that includes them all and that you can treat like the cages we've seen for the individual shapes. So rotate it, move it, and scale it. Any object you create in Womp, we are told, however, cannot exist without being within a union, even if it is by itself. So the software will automatically create a new union, whether we create a new one or move an object out of an existing one. So from here at the top, we can add a new primitive, but then we can interchange it with another one between cube, cylinder, or sphere, by clicking here in the other panel on the right, or if at the time it's easier to select it from the list on the left, we can do the same thing by hovering on it and use the last swap primitive between these three icons, or also by pressing here on these 6 dots. This drop-down menu will come out where we can select Replace With. The three icons here, therefore, are the essential lever of the full menu. With lock, we can lock the body so that all its functions visible on the right will freeze, so it will no longer be possible to move it, rotate it, and everything else. With the eye, it will be possible to hide or show objects, and if we open the drop-down menu, the corresponding option is Hide. Then we see that we can also copy the body and also duplicate it. Even faster, you can do it with the keyboard shortcuts shown here, Ctrl+C and Ctrl+D. We can delete with delete, but also actually by pressing delete or even the backspace key on the keyboard once we have selected our body. We can send it above all those in the group or union by pressing send to top, or above just the previous one with send to up, and equally in the reverse direction with bottom and down, one position further down. Of course, for a short list of bodies, it is also most convenient simply to drag over or under the body's boxes. And with move out, of course, it is possible to move our selected shape out of the union and automatically another one will be created, in which it will stand alone. The most interesting option, though, is definitely this one here, positive or negative, which we then find the same on the right as well, and that allows you to make a shape even negative, like this sphere that we see here inside the cube. In fact, you can see it explicitly, but we know it is here. And it's matter that it's subtracted from the other shapes once it comes into contact with us, either entirely, like now, or even just for a part, and it will appear next to it here, this red and white striped symbol to indicate as it's being negative. The important thing to remember, though, is that the order in which these bodies are listed on the left is not random, as the negative shapes must always be below the shapes from which we want to subtract them. In fact, if we try to move this sphere above the cube, we see how it can no longer dig it out, while the other positive sphere still can, and if instead we select this same sphere here at the top, we are told that it is not possible to make it negative, as there are no other primitives above it. Also, on the right-hand side, we find the Goop option, which is one of Womp's most unique functions and reveals a special and innovative way of thinking in 3D. Goop essentially means sticky, viscous substance. So goop not only affects geometry, but also blends materials, allowing you to work without worrying about meshes, construction lines, and thus the schematic nature of canonic 3D. We can compare the operation of goop to the behavior of so-called ferrofluids. There are compounds of ferromagnetic nanoparticles suspended in a fluid vehicle. Very often this is an organic solvent or simply it is water. So as goop increases, the fluidity, we might say, of our bodies and the outermost parts will be as if magnetically attracted to the bodies closest to them until they merge together. But it is not precisely so. It is not just about proximity, because there are hierarchies between primitives given by their position on the list on the left, we said it before, and the goop of shape occurs only with bodies above it and in the same union, but not necessarily in the same group. We see first that the goop of this pink sphere is not freezable, again, because it has nothing above it. Then, what binds it to the cube is precisely the cube relative to the latter one. If we decrease this value to 0, the two shapes become completely separate. Whereas if we increase it by a lot, we will have this effect of swelling the mass of the cube to merge with the one of the sphere until it almost encompasses. You can also here type an exact number, of course, in text box, for example, if we want to match the goop of two different objects. If we try instead to add a cylinder by itself in a new union that will be above the previous one and try to make it interact with the goop of the cube, we will see that it does not work because they are two different unions. While if we make a subgroup between these three pre-existing elements and then another group only with the cylinder, like I'm doing, and put them in the same union, we see how in this case we have a result. Let's go analyzing where an object is in the negative way, for example this same sphere here inside, and therefore the force of the goop will change the shear effects, that is, of the subtraction surface. So the negative effect of the object increases as we increase the force of the goop, as we were inflating a balloon that, however, consumes material it encounters. We mentioned, however, that the goop not only merges 3D objects into creations, but also the materials applied to each of them. So it is time to figure out now how to color and characterize our scenes. Materials can all be found here in the second icon in the top bar, and with the latest update many have been added. But unfortunately, as many have become available only for the Pro version, like other modeling and expert functions. As we have said in the previous videos, Womp is constantly evolving, and we don't know what else is in store for us. For now, the Pro feature has a 30-day trial period, and then it will need a payment. Maybe later on we can take a look at the new features developed in the Pro mode to get the full picture. For now, we see that the materials we can choose from are divided into categories. First, we have the ones that we have recently used, and here we will find the materials we created by modifying an existing one. After that, we have the metallic materials, and plastics, soft materials or rubbers, below the human skin's colors, mirrored materials, and finally all textured materials such as wood, stones, bricks, clays, textiles, and other blends. But these are all not usable in the basic version as they are marked by this little crown precisely. Now let's see how to edit a material by selecting our desired body and clicking here on the right. We are presented with a panel in which we have here at the top in real time the representation of our material, and below we start with the 4 parameters. Metalness is equivalent to metal, which is actually a set of more complex parameters of interaction between the material and the light, but which is, in short, makes us perceive the material gradually as polished metal. Then we have roughness, which is the roughness of our material, and the opposite, so the value 0 corresponds to smoothness or shyness. Next we have the glass option, which allows us to make our material at the highest value completely traversable by light, and like glass you can see through it. And finally, translucency allows light to pass through it, but in a diffuse way, so you can see right sharply through them, and an example might be frosted glass. So we can adjust these parameters as we want, and then of course we can change the color too by clicking on this little thing here on the right representing it, and then click this box and change the slider here at the top left. We find pure white, and moving down along this vertical we gradually decrease the brightness until we get to pure black. While moving horizontally at any value of color brightness, we have the increase of saturation, which describes the amount of gray present in our color decreasing towards the right, and consequently, conversely, the intensity of our pure color increasing toward the right. Instead, below we can change just the hue. So in simple terms, the colors we give a key name to it in the visible spectrum. So yellow, red, green. For example, we take any green from here. Or we would like to point out for those who have a minimum knowledge of color system that of course these RGB values that indicate the contribution of red, green and blue in the final color are changeable if we need to get a certain result. And the same with the hex index that identifies colors with specific codes according to this other well-known system, X. So you can copy and paste the code from other sources if needed. With this icon here, we can start a shuffle that is simply any material will be randomly assigned to our body, and instead if we click duplicate, we can have a copy of this material among our personal ones, and we can apply it to another object, for example to our cylinder. After that, with this other icon, we can select all the objects in the scene that have the same material applied if we find it useful. So, for example, let's add yet another cylinder to this scene and repeat. Let's be careful how we arrange our bodies in general, because we said that the group of any object happens only with those above it and in the same union. We then increase the group of the cylinder below it and change its color and metalness. So we can create a gradient of colors and materiality, which you can then use to add shading or shadows to our object, even when you do not want to change its shape. Even in case of a negative group, all of this happens. And if we see our negative sphere, if we change the color to a more noticeable one, like this, and increase the group a little bit, a gradient is created in the concavity. Whereas if we reduce to 0, the gradient will not be there. It will be a sharp transitions of colors. Now we can analyze the last few options for today. So if we go to press the last option above, we find the function menu, in which for all intents and purposes we have the same functionalities that we have already seen separately, and that opens to us automatically even if we select more than one body by holding shift. With duplicate, we can create a copy of one or more selected objects, and the copies will appear right above the original, and so they should be moved where we want, which then is the same as we could do with Ctrl D. With union, we can select the desired objects and enclose them in a new union. And now that we talk about the group, we can also say by clicking here on the left on union in the object panel, we find the child group option. In a union, each component is called child. So together the components are the children, and we can adjust the group of all together indistinctly, whether they are positive or negative, or what position they are in the list. Same thing we can do with the material, so we can easily assign an identical material for all these bodies. Immediately below we find the resolution, indicated by this percentage scale, which therefore allows us to increase the quality and sharpness of the image details. But be careful, because we're told that it is still an experimental function, and also that if we increase the resolution too much, this will require a lot of effort from the processor and therefore slow down all of our actions. So it is not advisable to keep it high, at least while we are still proceeding with our object. In conclusion, the group option, we said it is just useful to better sort out list of objects as in subfolders, while subtract causes all the selected objects except the first one up here to become negative, and therefore their intersecting shapes will go subtracted from the first one. Mirror instead is the same option as we have already seen in last lesson, even with multiple bodies together. Well, I think that's it for this video. Thank you for watching so far. If you liked it, leave it a like and comment for any question. Subscribe to the channel, and if you like, you can also join as a supporter for us to create many more videos to come. Thank you. See you in the next video.